Hello everyone and welcome to my channel. Today we have a question which says the correct increasing order of bond length among the following is. Okay, so we have to place these molecules, neutral, cation, anion we have been given, and we have to identify the correct increasing order of the bond length for these molecules. So if you have some idea regarding the ionic radius or bond length, consider this the atom which has a central nucleus containing positive charge, and then we have the electrons surrounding it. Okay, now let's discuss what happens in case of an anion. So in case of an anion, we have an additional negative charge, as you can see here, given as O2 minus. So what happens in case of an anion? We have an extra electron. So we have, let us suppose we have some inertial electrons, and then we have an additional negative charge. So this additional negative charge is the additional electron. Okay, so what happens when we have an additional electron? Then the inter-electronic repulsions are more. So the inter-electronic repulsions are more. So we have, you can see electrons in every shell, and these electrons are repelling each other continuously, and this repulsion of electrons, this inter-electron repulsion, leads to an increase in the electron cloud. Increase means the spreading of the electron cloud. So this leads to an increase in the bond length. So we consider the ionic radius. Since it is an ion, we consider from the nucleus to the outermost valence shell. So this radius increases. So when we have additional electrons, that means in case of an anion. So what happens in case of an anion? We have additional electrons, okay, and these electrons cause inter-electronic repulsions, and because of these inter-electronic repulsions, the electron cloud spreads, and this leads to an increase in the bond length, or specifically the ionic radius. Because it's an ion, so we call it as ionic radius. This happens in case of anion, and when the negative charge, as it progressively increases, if there is more negative charge, then there will be more electronic repulsions, more spreading of the electronic cloud, and resulting into the further increase in the bond length or ionic radius. So this is the basic thing that is happening in case of an anion. And one thing more that you can find in your textbooks, another reason is that as the anionic charge increases or the negative charge increases, then electrons are further added in the valence electronic shells. So number of shells also increase, which increases the distance between the nucleus and the outermost shell. So that's also logical that this increase in the number of shell and increases the distance between the nucleus and the outermost shell. So that is another reason why the anions have a larger bond length or ionic radius. Now what happens in case of cation? So let's say in the neutral form, the particular oxygen molecule has this number of shells. Let's say that is the neutral form, okay? And what happens in case of cation? When the neutral form changes to a cation, then electron is lost, okay? There is loss of electron. That means you can say that this entire shell is gone. Then what happens? Previously, what was the situation for the neutral molecule? Suppose this is the valence shell. We are just supposing, we are not drawing any actual diagram. Let's suppose that this is the valence shell, and from here it loses an electron to form the cation. Then this entire electron, this is gone. And before that, what is the ionic radius from nucleus to the valence shell? Till here is the ionic radius. And when the electron is lost, then what happens? So electron is lost. Fine. Then what happens? You can see here that the ionic radius shrinks to this much size. That means in case of cation, the ionic radius decreases. And why this ionic radius decreases? First of all, One of the shells with that outermost electron is gone. That reduces the ionic radius, and also the inter-electronic repulsions that was there previously with the electron in the neutral form, that also reduces. Okay, so inter-electronic repulsions also reduce, and due to this reduction in inter-electronic repulsion, the nucleus, the positively charged nucleus, now attracts the remaining electrons more closer towards itself. Okay, so the ionic radius actually shrinks, it decreases. So if we compare between the neutral molecule, cation and anion, the increasing order should be as follows. So cation is the least, having the smallest ionic radius or bond length, followed by the neutral molecule, and lastly the biggest or the largest ionic radius is for the anion. So I hope you understood the explanation, and based on this explanation, let us solve this question. So it's not a very difficult question. You can easily do it if you have the knowledge, and this is all a part of the chemical bonding and general chemistry. So option A says cation, then neutral, then anion with one negative charge and anion with two negative charge. B says cation, neutral, anion with two negative charge is smaller than one negative charge. No. Option A should be the correct increasing order of bond length for these following oxygen ions and the neutral oxygen molecule. Okay, so option A is our correct answer, which says that O2 plus has smallest bond length, followed by O2 neutral, then O2 with one negative charge, and O2 with two negative charge has the largest bond length. Since an electron is further added in O2 minus, so it will be the anion having the largest bond length. So I hope this is clear, and if you have any doubts or queries, please write to me in the comment section, and please do not forget to like, share and subscribe. Till then, thanks for watching, keep learning, and see you soon in my next video.